Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, welcome back. So this problem, we're going to use several skills that hopefully you've been understanding and developing over these videos, over your time doing physics and math. All right. So in this problem, we have three vectors. The first one, which I will call vector A, starts at the origin. Oops. Or something like that, forming an angle of 35 degrees with the x-axis and has a magnitude of 145 units. I'll just leave the units off there, I think. All right. Second vector forms an angle of 65 degrees with the vertical line, right? With north. The third vector, starting from that point, forms an angle of 15 degrees with the vertical. All right. So in this problem right here, we want to solve for the magnitude. If this is vector A right here, vector B, vector C, we want to solve for the magnitudes of vector B and vector C. So hopefully you see this triangle right here. It's kind of buried in a lot of lines and markings, but we're going to do a lot of things with this triangle right here. It's a pretty special triangle, I guess. All right, so we've got first we need to find each of these angles right here. This one, and this one. So we know that this angle right here, just this one part of the angle, is going to be equal to 15 degrees because this angle right here is 15 degrees and they're along parallel lines with an intersecting line. So the inside angles are going to be equal to each other. So this right here, this little part of the angle is 15 degrees. This part right here we can find by doing 90 minus 35, which is 55, which means that that full angle, I'm going to redraw my triangle over here with our measurements. Oops. I'm going to draw the triangle and I'm going to draw it on the board too. Well, that'll be a challenge, but I have faith that it'll work. All right. So this angle right here was, what did I say? 55 plus 15, so that's going to be 70 degrees. All right. This angle right here, we can find that by taking, over here we have a straight line, so that's 180 degrees minus 65 degrees minus the angle we're looking for, minus this angle, minus this angle right in here, which we can find that angle by extending that line, saying that's 90 degrees. 90 minus 35, rather 180 minus 90 minus 35, that gives us 55 degrees for this angle right here. If we do 180 minus 65 minus 55, that gives us 60 degrees. Then once again, we have another triangle right here, which has a total of 180 degrees inside of it. So if we do 180 minus 60 minus 70, we will find that this angle right here is going to be equal to 50 degrees. All right, and we have this magnitude right here, 145 units. So using the law of sines, we can find the magnitude of B and C. Whoa, that was a strange marking right there. In case you were wondering, that was supposed to be an A. All right, so the magnitude of A is 145. Finding the magnitudes of B and C, we can use the law of sines then. So that is if we have a side, this side right here, over the sine of its angle, which is the angle opposite of that side. So this side right here, this angle right here, it's going to be equal to that same idea, a side over an angle anywhere else on our triangle. It's a pretty nifty law if you didn't know it. Now you do. We'll find B first. We could find C first. It doesn't really make much of a difference. I'm just choosing it to choose it. So we have B and the 70-degree angle because that's the side and angle combination that are opposite of each other. If we multiply both sides by sine of 70 and plug that into our calculator, we'll find that B is equal to 177.87 units. We can do the same thing for side C. Sine of the angle, let's see, we're looking at the angle 60 degrees right here. And again, multiplying both sides by sine of 60, then plugging it into our calculator, we'll find that C is equal to 163.92 units. All right, and there it, oops, I should circle those, right? Put a box around it. There are your answers.